In this lecture, we are going to discuss the second type of the detection, double sideband full uh, carrier detection. The second one is the rectifier detector. As the name rectifier, so it means that we are using a switch or diode. Uh, the name of that is rectifier, means it will rectify a portion of the signal and it will allow to pass the other cycle of the signal. So the circuit diagram of that is this one, like the diode, resistors, low pass filter whose center frequency is FM, and then we are getting the low pass signal. After that we are using the DC blocker, and then we are getting the message signal here at the output. So we know that the amplitude modulator signal is AC 1 plus mu of mt and cos omega ct. So so it means that this is a sinusoidal signal which has a positive peak and the negative peak. So, and we know that, so this is the diode whose this side is P and that side is N. So if the P side is getting positive cycle, then the diode will work as a forward bias. But if the P side is getting negative cycle, then the diode will work as a reverse bias. In the forward bias, the diode will act as a closed switch, and in the reverse bias, the diode will act as a open switch. So it means that we are getting the VIT after the diode. So that is the modulator signal. So this one is the modulator signal multiplied by some periodic waveform. The waveform of the periodic is this one. So you can see this is half duty cycle, because it is off for the half of the time and on for the other half of the time. And we know that the PT, the pulse, for this is already, we have already given that equation in our previous when we used modulations. So that is 1/2 plus 2 by pi cos omega ct minus cos 3 omega ct by 3, and then plus other terms. So if we use this in this equation, so you can insert here. So VIT will be equals to AC 1 plus mu mt cos omega ct, and then multiplied by plus other times. So if you multiply this with that one, so you will end up, if you multiply this with the first part, so that is AC by 2, and then multiply with that one, it is 2AC by pi, and then mu mt, and then cos, so it will be cos square omega ct plus other terms. We know that we are using low pass filter whose center frequency is FM. So we are not interested in higher order, in other terms, who has frequencies much bigger than that. And we know that cos square omega ct is equals to 1.21 plus cos 2 omega ct. So use that formula here, and you will end up AC 0.2 1 plus mu mt cos omega ct plus 2 AC upon pi 1 plus mu of mt, and then again multiplied by 1/2 cos 2 omega ct. So we can again rewrite that over there. So Vit is equals to AC by 2 and then 1 plus mu of mt cos omega ct plus 2 multiplied by 2, so it means that it will you can take it out. The answer is AC by pi and then the meaning is 1 plus mu of mt and 1 plus cos 2 omega ct. So if you multiply this with that one, so it will be equals to AC by 2 cos omega ct plus AC by 2 mu mt cos omega ct, and then this term, this whole term with that one, AC by pi into 1 plus mu of mt and then plus AC by pi into 1 plus mu of mt and then cos 2 omega ct. So frequency of this one is Fc, frequency of that one is Fc plus minus Fm, because this is again double sideband signal. So the remaining is this one. So if you multiply this with 1, so it means that the frequency is equals to 0. The frequency of that signal is Fm, and for this case you see the frequency of that is equals to 2Fc and the frequency of that will be equals to 2Fc plus minus Fm. So after the low pass filter, so whose center frequency is Fm, who is center at Fm, so only signal whose frequency is Fm or lesser than that can pass, and all the other signal will be stopped, like here. So this will not allow to pass, this will not allow to pass, again this will not allow to pass, this will not allow to pass. So after the low pass you have BOT, so which is equals to AC on pi, so 1 minus mu of MP, so you can say it is AC by pi plus AC by pi mu of MT, and then after DC blocker you will end up with the YT, so this will be blocked by DC, the DC term blocked by DC capacitor, DC blocking capacitor, and the output will be this one, which is equals to AC by pi mu of MT. So you can see that is the desired signal, so which we can get by using the rectifier detector. So that's all. I think you understand the rectifier detector very well, but if you have any question, you are most welcome. You can write your question in the comment box. Thank you for watching the video.